Hi everyone, I'm Tiana.
And I'm Helen, and we're going to talk about soap.
There is many different kinds of soaps for many different uses, and so we're just going to talk about all the different chemicals inside of them and what makes one better than the other.
Correct. But we're going to mainly just concentrate on this one. This is liquid dish soap. We got detergent for your dishwasher and just rinse dish soap. If you ever were wondering why you can't use dish soap in your dishwasher or the other way around, yeah, well, we're gonna help you out with that one. To keep it simple in the beginning, we're just gonna say that soaps are made up of water and different types of oils, and this is just gonna help us kind of understand the foundations. In the case of water, there's slightly positive hydrogen that is attracted to the slightly negative oxygen, which is H2O. And the water molecules will form a weak bond, that's called a hydrogen bond, but it is strong enough to hold the water molecules very attracted to each other, which creates surface tension.
Fats and oils, on the other hand, are made up entirely of chains of carbon and hydrogen atoms. Carbon and hydrogen atoms also form covalent bonds, but they are non-polar covalent bonds, which makes them neutral atoms.
A chain like this one is called a hydrogen chain,
which is very important in detergents and soaps.
A physical property is a property of a substance that can be observed without changing it into something new. An example would be color, shape, texture, and weight. A physical change is a change that doesn't alter the substance itself. This would be something like cutting, bending, or freezing something.
With this in mind, we're going to show you an example of soap and detergent. Soap is a thick liquid, not really that thick, but you know, it's kind of thick. It smells good. It, when mixed together in bubbles, which you guys should all know, it is kind of a slimy and sticky liquid unless you add water, and it has very low surface tension.
And detergent packets, on the other hand, they're really sandy and compacted on the bottom, and on the top they have all the two soaps, and it's contained in a plastic shell. And the reasoning for that is that when it's compacted together, you don't want it all over the place in a bucket, so you put it all together, and once it's thrown inside the washer, the soaps come out and so does the powder at the bottom. Now we're going to talk about the chemical properties in both soaps.
A chemical property is a property of a substance that describes how they react with other substances. An example would be burning anything or resting iron. These are also good examples of a chemical change, which is a change in matter that produces one or more new substances. By burning wood, you're left with ashes, which is a new substance.
Soap is a water-soluble sodium or potassium salt of fatty acids. A fatty acid is made up of fats and oils and has a weak acid composed of two parts. Those two parts is, for one, our hydrogen chain from before, that's made up of carbons that are attached to hydrogens, and a carboxylic acid group. That's what
when combined, looks like this.
Combined, that's what they look like, and it creates, this is a fatty acid. This one is made up of one hydrogen, two oxygen, and one carbon. And plus, together with this, it creates fatty acid. But that's not all that soap is made of. Together with the fatty acid, there's also something called alkali. Alkali is a salt of an alkaline metal, like sodium or potassium. This particular one is NaOH, which is sodium hydroxide, and it's kind of like this, and this forms soap. This is the chemical makeup of soap. Oh, this is how you spell alkali.
Detergents are an anionic surfactant, which are made up of fats and oils to produce new acids similar to a fatty acid, which reacts easily with hydrocarbons. This is a hydrogen chain, like we discussed earlier, and when combined, looks like that. The second reaction adds a alkali to the new acids to produce one type of anionic surfactant molecule, which looks like that.
This is the basic structure of pretty much any detergent.
Or soap.
No, just detergent.
We're cutting that out. This part of the anionic surfactant is attracted to water, and this side is attracted to dirt and soil, which makes it go like that.
When this side finally wins and reaches a dirt or soil or oil, whatever it reaches, it will wrap itself around it and just go to the water. So it will remove the dirt or whatever there is on a pan, plate, cup.
Anything, any type of dish or utensil. Where? This, again, is an anionic surfactant.
And we conclude out of our research about the different makeups of the different parts of the surfactant that it has a lower surface tension, creates more bubbles, and is made up of a synthetic chemical. This synthetic chemical is actually bad for your skin because it removes the oils and tissues, and it's just not good. That's why detergent only goes in the dishwasher, because it doesn't have any skin contact outside of its all plastic thing. So we conclude that the reason that the detergent is better for your dishwasher is because the chemicals are just different and better.
See, as the chemicals in your liquid dish soap are more like cautious of your skin. They're more, like you're able to actually touch the soap. Other than this, it can actually like burn or something. I think it can burn your hand once it reacts with water and if you're touching it.
So if you remember from way in the beginning, and we talked about the carboxylic acid group, that is the difference between the chemical and the carboxylic acid group. This is more friendly to skin. This is kind of better for cleaning. There you have it, people. Me and Tiana fixed it.
Your problems have vanished.
So now, whenever you are washing your dishes, you will think of us and think of the chemicals involved and
remember
what crazy things actually going on while you're washing your dishes.
And remember not to use this when you're hand washing dishes. And don't put this in the dishwasher because it jacks up your dishwasher and you don't want that to happen.
Because dishwashers are expensive.
Yes.
Okay. That was it. Hi, Miss Pender.
Hi, Miss Pender, and hi, fellow peers. I hope you enjoyed our video.
Oh, look, there's a little sunshine.
Hey, let's cascade.
Okay.
My sunshine,
My only sunshine,
you make me happy when skies are gray. Okay. Now we are going to talk about the. There's people. We weren't going to talk about the chemical properties, but.
You still have to make homework for tomorrow? Make homework? Mom, it's stupid.
Hi! Oh, are you going?
Yeah.
Hi!
I love that little picture.
Okay, Victoria, we need to finish this. Bad for skin.
Where's the scissors? Give me the scissors.